at work done. But this time we are going to relate the work done with energy, kinetic energy, potential energy, right?
Okay.
Okay, so you read example 5.2.
Suppose that in example 5.1, the coefficient of kinetic friction between the loaded 50 kg sled and the snow is 0.2. The man again pulls the sled 5 meter, exerting a force of 1.2 times 10 to the power 2 newtons at an angle of 0 degrees. Find the work done on the sled by friction in the network. Repeat the calculation if the applied force is exerted at an angle 30 degree with a horizontal.
Okay, in the first case, the man is not pulling the sled at an angle of theta degrees. No, he is pulling horizontally, same level as the load, or parallel to the snow, to the surface of the snow. Okay, so if this is the case, then all the 120 newtons will do the work. You look at the diagram here, the force diagram here. Okay, the force diagram here. This black line is the surface of the snow, and the force of 120 newton is acting horizontally parallel to the snow. Then we know that frictional force is also along the surface of the snow, and it is parallel, but it is opposite to the direction of motion. So we have 120 newtons going to the right, and the frictional force going to the left. And under such condition, the man managed to pull 5 meters. Okay, 5 meters, the distance moved. Oh, we see that the force and the distance moved, they are in the same direction. So work is done. All the force is used to do work. Right. Before we can calculate what is the work done by the friction, you have to calculate the frictional force first. And how much is this frictional force? Okay. So we know the frictional force is F equals to mu n, where mu is the coefficient of friction and n is the normal reaction to the load. They have given us the value of mu 0.2. The coefficient of friction is 0.2. The normal reaction you have to know. They will not tell you how much is the normal reaction. In this case, the normal reaction is equals to mg, because if you look at the diagram here, mg is acting downwards, the normal reaction is acting upwards. So the normal reaction is equals to mg, right? So the normal reaction is equals to mg. So what is the frictional force? The coefficient of friction, 0.2, multiply with the mass 50 kilogram, and the g 9.8. Right? So this is the frictional force. So the first part, they say what is the work done by friction. So work done by friction, you have to use the frictional force multiply with the distance moved. Of course, the distance must be parallel to this force. Okay. So the work done by friction is the frictional force multiplied with the distance moved, 5 meters. Frictional force, we get it from the top here. We have already calculated the frictional force. So frictional force multiplied with the distance, and because the frictional force is in the negative direction, so you put a negative sign in front, right? So the answer is negative 490 joule. Next part, find also the net work. Actually, this one is net work done. It is not one word, is two word here. Net work. Let me draw the underline. This one is net work, is two words. It's not one word. If it is one word, then we are talking about the networking, the net. Okay, but this network means the extra force, the net force, the excess force. How much work is done by the excess force? Now, if you look at this diagram here, the force exerted is 120 newtons. The frictional force is 490, negative 400. Sorry, this is work done. The frictional force is how much? 0.2 multiply 50 multiply with 9.8, so it's about 90, right? It's about 98, like that, around that. It is less than the applied force. So when the applied force is more than the frictional force, there will be a net force, the excess, the difference between the applied force and the frictional force. There will be an excess. So this excess, we call it the net force. And how much is the net force? We're going to calculate the net force. The net force is how much? The net force is this one, right? 120 minus 0.2 times 50 times 9.8. Oh, the net force is 22, right? The net force is 22.
22
So this
Newton.
is actually 98. This is actually 98 newtons. So the net force is 22 newtons. This 22 newtons is the difference between the applied force and the frictional force. So this net force, still they can do work. So the work done by this net force is called the net work. It should be net work done, then people won't confuse with the word network, right? So over here, I write down how much is the total work done. The total work done is this force 120, right? Multiply with the distance moved. So the total work done is 600 joule. Okay. This is the work done against friction, 490. This is the total work done. So there is a difference in the work done. And this difference in the work done is actually the net work done. So net work done is 600 minus the 490, which is the work done against friction. So the net work done is 110. Okay. This 110 joule is not used to overcome friction. It is used to move the object. It is used to move the load 5 meters. So this is the net work done, the energy needed to move the object. Any questions so far?
No questions, sir.
No, that means you know what is the net force and what is the net work done. Okay, now we have a second case. The second case is exactly like the diagram here. The force is not the applied force. This blue arrow here is acting at an angle of 30